Alright, so let's go ahead and wrap up 2.4 by doing what I call just wordier word problems, if you would. Lots of words involved, but again, the same dynamic. Step 1, write your relationship. Step 2, plug in information and find your constant. Step 3, rewrite your relationship with your found constant, and then answer any questions by plugging some stuff in. So that's what you're going to see me do here, despite the fact that things are a little more complicated. So we're told that the intensity of light, I, varies inversely with the square of the distance d. Alright, so that basically says that I, right, equals some constant. We're not talking about a square root, right, because there's no word root. So we're talking the square of d, so that's d squared. So there's our interpretation of that first part of the word problem. Second, hopefully there's enough information to find our constant. So a distance of 2 meters, right, so there's d, creates an intensity of 3/4 foot candles. Well, there's your I. So 3/4 is equal to k all over 2 squared. And then putting things in motion, this is k, that's equal to 4, right? If we multiply both sides by 4, we basically get that k equals to 3. So our intensity is 3 over d squared. So step 1, step 2, step 3. Now I can answer anything anybody throws at me. So what are they throwing at me? What is the intensity created when the bulb has a distance of 5? So we know the distance, we're trying to find the intensity. So I is 3 over 5 squared. And so I equals 3 over 25. And again, in terms of units, this would be foot candles. So 3 over 25 foot candles is our final answer to that particular situation, right? And again, you see all our four steps, right? First step, write the relationship. Second, plug in what I know to find the constant. Rewrite the relationship with that info. Plug in what I need to find out whatever it is they want me to find. Last one, the volume V of an ideal gas varies directly with the temperature T and inversely with the pressure P. So again, we have one of those mixed or compound variations. So V varies, right, the volume of an ideal gas. So V equals some K, right? Well, with respect to the temperature T, it's direct. And with respect to the pressure P, it's an inverse. So there's your direct with respect to T and your inverse with respect to P. Right? So is there enough information? There's step 1. Step 2, what do we know? It says a cylinder of 50 liters. Now liters is a volume, so there's your V. Contain oxygen at a temperature of 20 Kelvin, so there's your T. At a pressure of 5 atmospheres, and there's your P. So 50 is equal to some constant times 200, right, all over 5. And in terms of solving for this, perhaps 5 goes into 24 times the remainder of 0, so we're basically looking at k times 40. Divide everybody by 40, do a cancelization, we have 5/4. Alrighty, so our relationship then, part 3, our volume is 5/4 times T all over P. This fraction can be written like that if you want, or you can whatever you want to do. But 5/4 times T is the same thing as 5/4 times T over P. And so whatever rocks your world. So now, right, step 4, let's plug in what we know. They want us to know, right, what would the gas pressure be, right, if the volume was changed to 30 liters and the temperature was raised to 250 Kelvin. So in this case, we know the volume, it's 30. We know that the temperature is 250, right, our 4 down there, and then the P is what I'm trying to solve for. So there is our equation. And so let me write this as 30 over 1. If we cross multiply, we get 30 times 4P, and let's see, 250 times 5, 0, 5, carry the 2, 1250. And so we get 120P equals 1250. Divide both sides by 120, and we have our pressure. Simplifying this, I see a couple of zeros canceling out. Let's see, anything else in there? I think that's it. I don't know. Let's see, 1, 2, 3, nope, 4, 5. I think that's it. So we're basically looking at 125 over 12. Yes, 125 over 12, and this would be atmospheres, because that's how we're measuring the pressure. And of course, you can change that to a mixed number. I think that would be, let's see, 12, 10, 11, and 3/12, or 11, I guess there was, right? 11 and 1/4. Alrighty, so atmosphere. Alrighty, so there would be our final answer in terms of a mixed number. And there you have it. So again, all these variation problems have the same rhythm. Write your relationship using the language, plug in information to solve for a constant of variation, rewrite that relationship, and then plug in what I need to find the variable that's missing. As usual, if you have questions, please ask. Get with me with the virtual office hour, jump online and ask on Canvas if there's something that needs to be clarified in a video or in your homework, whatever the case might be. But that wraps up section 2.4, pretty much chapter 2 in our text. Now we're ready to go look at chapter 3, and I'll see you guys in the next module.